Good afternoon, everyone present here in the room and wherever you might be. Greetings from your director. I managed to cause quite a bit of confusion with sending my announcement today about the EOL seminar series. So here I'm standing in front of you actually to provide some clarifications on the words that were included in that email. I will leave the introduction of our guests today for Stuart or Steve. I don't know, maybe one or both of them will be doing. I just want to say that I am thankful for the two of them for stepping forward, to Stuart and to Steve stepping forward and serving as our co-coordinators for this new and improved EOL seminar series. The EOL seminar series refers to the regular monthly talks in EOL. The series composed of invited speakers, external speakers, as well as internal speakers. We've also asked people to internally step to the plate and present to us their scientific work. Again, on a regular monthly schedule. So what you see on the list that I sent is the next 10 months forward talks that we currently have. In addition to that, I just want to make sure that these are not envisioned to be the only seminars in EOL. We will accommodate other seminars. Our guests who come to the lab who are willing to present a scientific talk, we will be accommodating them as well. So you will be actually seeing more announcements of the seminars, not just those here on the list. Stuart, Steve, thank you again. For all of you, an action item to think about: who would you like invited? They do have a power to invite people to the laboratory, and then they will carefully take all your considerations into account. I know that they do have a long list, and they're working through it. So with that, I will turn to Stuart, who will announce today's speaker.
So, of course, many of you here already know Dave Carlson, are familiar with him from his time here before. But just for a brief biography of him, he received his PhD in oceanography in 1981. After that, he was a postdoc fellowship at the Naval Research Council. Followed that with a time as a professor of oceanography at Oregon State University. Later became the director of the International Project Office for the Tropical Ocean Global Atmosphere Coupled Ocean Atmosphere Response Experiment, with over 2,000 participants from 20 nations. In 1995, he became the director of the Atmospheric Technology Division, what we know as ATD here, of course, which pretty much morphed into what we now know as EOL. In 2005, he became the director of the International Program Office for the International Polar Year, which of course has over 50,000 participants from pretty much everywhere, from over 60 nations. From 2009 to the present, he is the chief editor of the Earth System Science Data Journal. Please welcome Dave Carlson.
Thanks, Stuart. Yeah, I've been on this stage a couple times. I want to talk about data publishing, and my view is going to have two parallel threads. One is this view from the front, which is from the journal publishing institutional view, but as well, I want to take a personal view as scientists. Publishing your data, do the outcomes justify the efforts? And as I go through, I'm going to try and track both of these threads. This really starts with the International Polar Year. The International Polar Year had a free and open data policy with appropriate caveats, but basically the most aggressive free and open policy that you can imagine. It was not new, but it was the first time a big program of this scale adopted that policy. But the result is this picture. The data is rapidly disappearing into the sea of data around the world, and I predicted that in 5 years from the start of IPY, you would not in fact be able to find any IPY data, and unfortunately that's true. So why did we fail so badly in such a big program? One is because it was highly international and highly interdisciplinary. And although there might be disciplinary or national services, there's nothing that encompasses the breadth of science that was in IPY. But the second is more of a behavioral issue, which is that there really are no incentives, institutionally, nationally, and especially personally, for you as a scientist to publish your data. There's really nothing in it for you. And that little piece of it we felt was a behavioral issue that maybe we could attack. If you start IPY again today, there's nothing international or interdisciplinary that will help you, but maybe we make a change on this behavioral side. So the question became, would data publication as a mechanism start to provide incentives for data sharing and data access? We did not want to get into the publishing world. We definitely did not want to start a new science journal, just the last thing that we need. But we use data publication as a mechanism for pushing this open access to data. And so we as Hans Pfeifenberger and I, and I'll talk a little bit more about that, we went to Copernicus, the publisher in Freiburg, and we said, we propose a new journal focused on data called Earth System Science Data Journal, ESSD. And in fact, we started it in 2008. Now that date is important because a lot of things happened in the 5 or 6 years since then. Among those are a series of reports that come out almost regularly, almost weekly. Here's one by the Royal Society. If you lived in the UK, you know that's, of course, the UK Royal Society. But look at the date, June 2012, Science as an Open Enterprise. And, of course, it is full of language, but let me highlight a bit of it. Communicate data. Well, that's a little odd because we often hear mandates to communicate, and we often hear mandates about data, but we don't usually hear the two of them together like that. A second is free and open access, and that's no surprise to any of you. But the third, which might be a slight surprise, is for a public audience. That is, this is not open access for science itself, but science interacting with the public. And the authors of this report, who we know very well, came and spent an afternoon with us at ESSD to see what we were doing. So, there are, in fact, dozens of these. Here's one from the European Commission, 2011. They actually mentioned ESSD specifically as an example. Here's one when the G8 met in 2013. The meeting was in Edinburgh, so the UK controlled the agenda, so open access was strongly on the agenda. Well, here's one that you should know about, but I suspect you don't. This is from the OMB, an executive order making government information open and readable. Of course, this is the same government that listens to my phone calls, so I wouldn't put too much stress on this. But it's one of a dozen of reports that are all doing the same thing. They're saying open data, freely available, accelerate breakthroughs, increase transparencies. But what's relevant to science is they're not talking only about government-produced data, statistics, surveys, etc. They're talking about government-funded data, federally funded R&D dollars, which means the dollars that probably everyone in this room lives on. So, not me, by the way. And if you haven't heard these messages, either individually or as an institution, you will soon hear them. They will be on your doorstep. So in that kind of world, let's talk about data publication. I call 3 levels of data publication. One is I call primary data publication, and you can think of this basically as do it yourself. You put your data up, you do the quality control, you do the metadata formatting. This is GBIF, the Global Biodiversity Information Facility. You can see they claim about 15,000 data sets, many publishers. It's basically a clickable toolkit that takes you to a website. And it's no different really than registering for any other website, for any other service. They give you some guidelines, they give you some metadata, They tell you how to upload large data sets. They make sure it's consistent with the registry, but it's your data, you load it, and it's your quality control, okay? So it's basically do-it-yourself using the GBIF toolkit. It serves the biodiversity community very well. I'm not critical of it. I'm just describing it. There's a second one that I call indirect data publication, which is instead of do it yourself, get someone else to do it for you. So send your data to Pangaea, and Pangaea will publish it, and therefore you say, I published my data. And Pangaea can likewise say that they are a data publisher. What's crucial here is that Pangaea was the data center that first started using DOIs, digital object identifiers, as applied to data sets. Not as applied to scholarly articles. You know, if you publish in JGR or GRL anywhere, you get a DOI at the end of it. That's appended by the publisher. You really have nothing to do with that. But this use of DOIs as an identifier for data, remember the DOI only comes into service in 2009. This is a crucial tool for data publication. Here's a Pangaea page. I use their GeoBrowser to search all the sediment traps in the Atlantic. They have a fairly generous definition of the Atlantic, and this is what it returns. You notice all the DOIs, but again, it's just a list of data sets, okay? It's Pangaea doing your work for you. I may know Mitch Lyle, I may know Rainer Gersund, I can find their data here, but if there's a quality control or any compilation or any value added, I don't see it here. These are the original data. So, and Pangaea, as I'll show you in a moment, has been very aggressive and in many ways is leading the effort to do this kind of indirect data publishing. But the data publishing that I'm talking about today is formal data publication. And by that I mean the formal steps that you think of with a science publication. You submit, you receive evaluation, you revise, you publish, you get a citation. So it includes that review step. And this is the newest monster on the block, Mike. This is Nature Publishing Group, largest science publisher on the planet, announcing a new journal called Scientific Data. Starts in May, accepting submissions now, and if you're on any kind of data list around the world, you're getting this announcement. They have excellent marketing. They have resources for marketing. They're going to play and intend to play a huge role in data publishing. And you see all the reasons. Credit, reuse, quality, discovery, open service. It'll be very interesting to see what the field looks like with nature in the game. This is a game changer, believe me. I'm not going to say more about that except to say that whatever their marketing analysis it's telling them that data publishing is a business and they're going to get in it. Here's the other one, and some of you in the room know this journal, okay? Geoscience Data Journal. This is a Wiley journal in cooperation with Royal Met Society, and many of you know Rob Allen as the editor. It's a startup effort. It's associated with Wiley. I don't know their costs, but there are some. And they have a couple issues out, a couple papers out. What really motivates behind them is a push in the UK that any UK investigator with NERC national funding has to make their data available. And this is regarded as a UK mechanism to make this happen. So that one has, how old, Mike? Maybe 15 months or something like that? Well, from the start, but when they've started to put journals out. So here's ESSD. Okay, this is the top page, the landing page. We've now been in action since 2009, so 5 years. Let me show you what's happening in ESSD. So this is the last couple weeks. Land surface air temperatures, global precipitation, upper air data. In this audience, I don't have to explain upper air. Wildfires, organic carbon, and permafrost. So you can see the variety of data sets that are being published in ESSD, and this variety is something we're deliberately cultivating, and I think any one of you would consider any one of those potentially interesting and broadly applicable broadly interesting topic. That's the outgoing. That's what was published in the last couple weeks. Let me show you what's in my inbox this morning. Ice thickness of Greenland, biogeography of jellyfish in the North Atlantic, and land use map agricultural catchment. Some of these are global data sets, some of these are local data sets, but again, the attention is on quality, broad applicability, and utility to a wide audience. Vonda.
You didn't define the word data. Is this limited to data that comes from observations living?
I'm going to show you by example that we take a very broad view with fairly limited fences, okay? It's not a rehash of a satellite image. It's not just a rebroadcast of a satellite image. And so far, in most cases, it's not a straight climate model output. But if you've actually put satellite image and model output and some ground data together, then that's the value-added piece that we're interested in. So in fact, it goes beyond purely observational, fixed observational data. So here's the process. To the author, it looks pretty much the same. You submit, you revise, and eventually, once published, you use that citation in your CV, your promotion tenure. But there's a new player in this process, and that's the data center. Because we, ESSD, do not hold any data. We're only the publisher. We're only the journal. So we require a data center partner. That data center has to accept the data. That's where the DOI gets assigned, and we'll talk about that. And to partner with ESSD, they need to be open access. And I'm going to show you open access. What I mean by open access is one click. No registration, no FTPs, no checking your URL. I mean one click open access, and I'll show you that. So. And then the journal accepts the description, and you'll see I'm going to use this table a couple times. Whenever I highlight something with yellow, that means it's more work. Okay, you have to be cautious. We actually run a peer review of data. And for this audience, you ought to know that that's a hard job. Okay, we want that reviewer to drive that data set. We want them to open it. We want them to see if they can reproduce the graphic. We want them to check the error terms. That data set, when it's published, has been thoroughly reviewed. But we're using, of course, the same review community that's reviewing the science papers. So this is actually our biggest limitation, is finding data reviewers. And there's at least one person, I'm looking around, there's at least one person in the room who's reviewed a data set for us, yes. And so that topic may come up again. We run an interactive discussion. I'll talk about that on the next slide. But then we publish the description with the DOI. And we're entirely open access. Our process at the moment, by the way, is entirely free. There are no paid charges, no data charges, nothing that requires you to give an account number. But this is where the DOI comes into view, because this DOI allows us to track between the data description, the data set held at the data center, and the DOI that you use in your citation. And without that DOI, we don't have version control, we don't have reliable descriptions, etc.
If I want them to sell there for the data center, so my question is, are you asking them or whoever is requiring, what is the time horizon of the data?
We say a decade. We say a decade from now, someone needs to come and be able to find the data, find the techniques that were used to make that data set and reproduce it. So that's our, there's another reason for leaving this gap. If you're at Pangaea, you are in fact publishing the data. You're saying, oh, we publish the data. But if you're at some other data center, like Zalf, for example, you're saying, oh no, it was published in ESSD. And so we don't want to argue over who published it. We want to make it available. So. Our review process looks pretty much what you would expect from science review. Editors, topical editors, anonymous reviewers. We do use this public interactive discussion. This is typical of the Copernicus journals, and it turns out it works very well. It can work very well for data journals. Britt, I think you commented on the one of the climate, the carbon, right? A good data set should draw a lot of comments. If this were on a different grid, I could use it for this purpose. If you had calculated this way, then I could do something like that. So we try to run this like the Google evaluation service, right? If you want to buy something on Google, you can send a question and say, did anyone else use this and how did it work? That's basically how we run this interactive discussion. It gets abused occasionally, but when it works well, parallel to the review process, you can get a dozen useful comments on your data set, you know, how to make it more useful. It's actually a test drive option. So, our review criteria are accessibility. Can you get the data? Quality, that's really the primary one. Can you trust it? Does it have the error terms? Does it have the uncertainties outlined? Can you reproduce them? The algorithms they use to do their interpolation, whatever it is. Needs to be well documented, that's the ESSD piece, and a broad impact. Even though it might be highly local or highly disciplinary, if we think that it has broader implication, then we tend to be very generous on the interpretation. We are currently indexed in Scopus. If you know that process in Europe, that's a big deal. That means that you get cited and the citations will show up. We're included in all the open access directories and backed up in all the right places. Copernicus does this for us. That's why we fit well in their system. So here's our record of publication. We announced in 2008. We started picking up a data set or two in 2009. We picked up a big ocean special issue in 2010, and that seemed to convince people that the journal was viable, right? That they could process a big issue, get the data out, work with data centers. And then there's a sort of lag as people start to get their data set ready, and now you see 2013 to 2014. 2013 we ran about 30, 35 in, 32 out. This is all at volunteer, entirely volunteer. So it's a big workload. And we are on track for 2014. We're going to hit 60 or 70. So Mike, thinking about the growth curve, I think there's this normal dip of getting confidence in the journal, seeing how they can handle, you know, seeing what the products look like. So if this grows much bigger than, well, even at 60 or 70, it becomes too much for two of us and the team to handle. So I want to run through some examples. I traveled to New Zealand a couple weeks ago, so I did this example. This is the Osborne and Jones Crew Temp 4 global land surface air temperature, and in addition to publishing the data, they published a KML interface, and so this is the KML interface. The data are gridded in 5x5 boxes, so the red and green show you the boxes, and then they show you the individual WMO stations that hold the data. And at any one of these, I was in Wellington, so I picked up the Wellington data set. You can pop up a little graphic, and then you see there on the right a little hot link for data. The data is dropped directly to your desktop. You don't have to sign in. You don't have to say I'm from .edu. It just pops right directly to you, okay? This is an interesting interface, and it's got quite notoriety. It's been quite popular. Because I'm going next to Portugal, I thought that New Zealand is antipodal to Portugal, so why don't I look at Portugal? Here's the same data set, now the same 5x5 grid boxes, and this is the Atlantic. Here's Portugal. Madrid is often to the right. Excuse me, Lima slightly to the south. So I picked this station, Coimbra. It's a WMO station, same data set. You get a little snapshot. You can get a larger image. You click on the data, it's delivered right to your desktop. But what's interesting about ESSD is when we get over here to Portugal, we intersect another ESSD data set. This one was published in 2012. It was published by the Meteorological Service of Portugal, and I can't remember the exact title, but it had the sense, homogenized and corrected data for surface land stations in Portugal. And they happened to produce a corrected Coimbra data set, which is the black one up in the top, and so we can actually put the two together, and you can see how the local data set fills some of the gaps of the global data set, and the global data set provides the context. Now you can say, as many of you said to me many times, Dave, you did that wrong. You should have done this, you should have done that. And my answer is yes, absolutely, I probably did it wrong. But the data are free and open. If you don't like the way I did it, download it into MATLAB and make your own plot. There's no barriers here. Everything's open. So, this is the global carbon budget. It has an interesting history, but it's working well with ESSD. This is the 2013 version, and this is the ocean sink. You know that the carbon budget is emissions in and atmosphere, ocean, and land out. And so this is the ocean sink. The data are produced by ocean biogeochemistry models. So, Vonda, this is an example where there's a mixture of model and observational data sets. In fact, the observations are only from about 1990 forward. So out of a 50-year record, there's only 20 years of observations. It turns out that we actually published the observations. This is the data set. It's called SOCAT, Surface Ocean CO2 Atlas. And it comes in a couple versions. Notice the black version, which was the first version, ended in around 2007. And now in the 2014 version, they've extended it a couple years. A couple things. I'm going to wander out of view here. They go back and correct things, right? They added some data here. They decided that there's some data in there that weren't quite right, and so they took them out. So this process of continually improving your data is something that a good data publication has to accommodate, because data sets largely are not static. So we have a version control system, so the new CO2 Atlas has its own DOI, and it refers back to the previous one. These are not actual values, they are numbers of CO2 measurements, all shipboard, and the units are 10 to the 5th. So in 1990, there were about 400,000 global measurements of surface ocean CO2, and then there was a peak in about 2005, 2006, and now it's dropped off. So if you can see the data that go into the green ocean models. So I was at a meeting in Tromsø, and we were talking about what is needed for the Arctic, because this is a global ocean CO2. If you look at the distribution, there are very few in the Arctic. We said, well, let's go and see what we could find for Arctic ocean data sets. And we found this one, and this was published in ESSD. This is the same scale, now number of observations, but only in hundreds. So there's only 200, 300, 400, maybe 800. And again, you see the same distribution, mostly in the 90s or 2000. This is mostly Beaufort Sea, Northern Pacific. This is iOS British Columbia data. But they said, oh, we think we have some old samples, and now we could go back and find the data and actually pop up some data from 1974. And you can see how important those are in the global record, because otherwise there's almost no data back that far. So this is data recovery, but targeted in the sense of where geographically and where in time is it important to pick that up. Because these groups, like the KML version of this, of the HADCRUT data, of the CRUT4 data, and the global carbon, because they put so much effort into polishing the data themselves, it becomes worthwhile to build a display system. So in the case of the Global Carbon Atlas, they built the Global Carbon Project, they built this Global Carbon Atlas. And again, because I was in New Zealand, I highlighted their 2012 emissions. Before we get feeling too smug, we can look at the US. Again, the point is, if you don't put all that effort into cleaning up the data, then it becomes worthwhile to actually build a display system, a communication system around it. I want to say one more thing about this data set. This is the BBC. Here's the carbon emissions are too high. It actually popped up on the home page. By the time I caught it, an image, it had already moved to the science page. But this is a data set getting global attention, and I especially want you to read this. Data published in the Earth System Science Data. I am not aware of another example of where one of our environmental or global data sets actually receives explicit mention in a science article on the BBC. Okay? It's good for them, it's good for us, it's good for all of us. A couple more examples. This is, Brigitte, open ocean chlorophyll. Okay? HPLC, it means there's chromatographic pigments. There are 36,000 samples. This is over 40 years, from 1965 to 2005, 1968 to 2008. You think 36,000 samples, wow, that sounds a lot, but you can see that most of the ocean is in fact a gap. This is part of the big Meridot database published in ESSD. And the gaps are especially acute in the Southern Ocean, but it turns out there's another ESSD data set called Southern Ocean Chlorophyll A. These sensors are carried by elephant seals, and you can see that I'll fade this out and then fade it back in. Even though it's a fairly restricted area, the local data set complements the global data set, but the global data set provides the context for the local data set. Let's finish with a stratospheric ozone data set. This is a global gap-free ozone database produced largely to support climate chemistry modeling. Greg Bodecker and team published it in 2013. What they're showing here is the modeled global ozone, monthly values, 16 kilometer altitude at latitudes greater than 85 south, so basically South Pole, okay? And they're using mostly satellite data. They're referencing it to ozone sondes, and their model actually incorporates natural, volcanic, and anthropogenic. Again, a freely available data set, especially important for climate and chemistry. And these are the observations that they have in this particular subset, this Antarctic, Central Antarctic subset. Well, it turns out you can see there's a little gap there in the late 80s. There's another ESSD data set, this from the German group for the Georg-Forster station. Those of you who know that station's at about 70 south. It's on the perimeter, eastern perimeter of Antarctica. And in this case, instead of number concentration, they're doing partial pressure, and they're actually only doing it in the Antarctic spring, and they're plotting temperature. But you can see how the local data set actually complements and fills in the global data set. Again, you can say, Dave, you used the wrong units, you did something. The data's free. Pick it up, do it yourself. Okay, here's where ESSD is today. It takes 2 years to get an impact factor. I don't like impact factors in any case, but so what I've done here is I've actually used the fact that all the Copernicus journals are open access, and therefore what I can track is all the views and downloads for each of those articles in each of those journals, okay? ACP, you probably know, Cryosphere, Biogeoscience, Ocean Sciences, ESSD. So what I do is I take the first 5 papers published in 2013 from each of those journals, and then I track their views and downloads out for 12 months. So by January 2014, I know a 12-month history, and then I show both the average, that is what is the average of those 5 papers, and I show a green, a maximum. Did you have a high impact paper sometime in those first 5 papers, and how does that play out? And you can see that ESSD is right in with Biogeosciences, Ocean Sciences. Remember, these others are not only Copernicus, but they're also society journals. They're all EGU journals, and they've all been around 10 or 15 years. So the fact that we're in the game at the level of some of the established journals, at least in terms of views and downloads, is very encouraging to us. What it actually means is that every ESSD data set gets looked at every day. And if you think about that as a data provider, that's a motivation for quality control, open access. You don't want that viewer to hit a 404 error, right? And so all the things that make data open access, this is a positive feedback on that. Okay, let's go back to the individual view. I know what you're saying because you send me these messages all the time. I gathered it, discovered it, earned it, it belongs to me. Well, that might have been true 30 years ago, but today it's no longer true. It belongs to the public, and our obligation is to get it in the hands of the public. I or my student needs time for analysis. This is interesting because most data gets lost at this step. Because the fact that you didn't commit at the time to make it available means that you always push that task either off or off to your graduate student, and in fact it never happens. Most of those data sets, as we were saying, are on departmental servers where somebody's forgotten the file name. So, I hear this all the time. Somebody will steal it or somebody will misuse it. The truth is, you know how many conference organizing committees I've sat on? I've never actually seen a tangible, provable example of either of these, okay? But I've seen hundreds of cases where nobody uses it and nobody looks at it. So what we're doing is we're insuring ourselves for a non-risk, and meanwhile we're missing the fact that by hiding it, by protecting it, nobody else is seeing it. So. But having worked here, worked with all of you, I know the real reason, and the real reason is it's too messy to share, right? If I actually had to take my data and clean it up so somebody else could use it, it'd be too much work. And that's where the data centers come into play, because that process has to be helped along by the data centers. So this is a list of our cooperating data centers. This is ACADIS. Is that how you say it? Okay. Interesting, this is not an NCAR data set, okay? Second, it wasn't minted here because it has a DOI and you don't do DOIs. So this must be a ACADIS data set registered at NSIDC. There's IPAV in France, British Antarctic Survey. There's another US data center, NCDC. There's a Norwegian data center, a Bjerknes Center. That one's in Sweden, another British one, another US one, NSIDC, just down the road, another British one. Think of the legacy data sets that BODC has. They go back to 1847 or something like that. Pangaea at AVI and CDAC, Carbon Dioxide Information and Analysis Center at Oak Ridge. I stop here. These two data centers have been extremely supportive of ESSD. They have opened their collections. They've adopted the DOIs. They've built new landing pages. They've understood this goal to have this one-click open access. So without the two of them, we really wouldn't have had a journal progress the way we've had it. Hamburg, another German one, another UK one, US Antarctic, another US German Weather Service, another US ESA, oh, I'll come back to that. New Zealand Geological Survey, another Norway one. This is ZELF. This is the hydrological data center at Leibniz. Denmark and Greenland. Zenodo. Does anyone here know Zenodo? Okay, there is a good one. I'm going to describe this, correct me as I'm wrong. We're just starting to work with Zenodo. This is a data center with, if you don't like anything else on the list, for personal, institutional, or peculiar reasons, try Zenodo is what we tend to say. So that's an interesting new partner, and we mentioned. This is not the World Data Center list of approved data centers. This is not the CODATA list of qualified data. These are just the partners who've agreed to us, and it makes a very interesting list.
So how does this work then? When someone submits an argument, data
And it has every flavor. A data set might come in and they say it's already at Pangaea. Check. A data set might come in and they say, we think we'd like to work with such and such, but we're not right in the right format yet, and then we'll enhance that interaction. A data set might come in and say, we don't know where to put this, will you give us a recommendation? So we have everywhere on that spectrum of how this plays out. And frankly, for the first 12 months, we just said send it to Pangaea, right? Because that was easy, and they're very competent and very friendly. But now we developed this longer list of partners, and it makes for a very interesting array. So let me try and do a little bit of summing up. For a science paper, you analyze, submit, revise, and then you get some kind of recognition, okay? For the data set, almost everything on the preparation side takes more work. As you prepare, you have to consult with the data center. Think of writing your science paper. It's a text and graphics. Here we're talking about formatted data, error terms, metadata descriptions, captions, column headings. We're talking about a whole variety of additional factors. And when you submit it, you not only have to submit it to the journal, but you also have to submit it to the data center itself. So it's got this extra step. Okay. Revision is the same way. When you get a reviewer's comment on your science paper, you say, well, I changed paragraph 2 and I added a sentence to paragraph 3 and I changed the axis label on the graph. Bingo. Okay. When you get a review from ESSD, it says, how did you calculate the error terms? How come you missed this? Why didn't you use data from... So it's actually a lot more work to do the revision. Notice that I say recognition is the same in either case. This we hope is true, and this is our intention, that the recognition you get from publishing a science paper is identical to, in impact and import, to the recognition that you get from publishing a data set. But my argument is that by publishing the data set, you then get these enhanced opportunities for discovery and reuse. And because you put all the effort into polishing that data set, it opens new possibilities for visualizations and communication. So remember, from the sort of the institutional world, the world of reports and unfunded mandates, we heard free, communicate, public, accelerate, freely available, increase, where actually what we're doing is ensuring quality, enhancing recognition, improving the exposure, improving the access, and building in this ability to communicate directly from your data. And even if we did not have these external pressures or mandates, this is fundamentally good for science. If UCAR wrote a data management plan, which they must have in their last cooperative agreement, it probably had words that looked like this in it. What I think has surprised us and been unique to ESSD is this ability to do the global and local connections. And in a time when we have global but low resolution data sets coupled or appearing simultaneously with local but high resolution data sets, this ability to move back and forth freely in formats and freely in access, I think, is very crucial for our science. So I'm suggesting that, in fact, the outcome does outweigh the effort. I'm not minimizing the effort. I think the effort is substantial. But I think the outcome is good individually, I think it's good institutionally, and I think it's good for science generally. I have to thank Copernicus. Without their opening their publication and review system to us, we couldn't have done this, especially Nadine and Natasha. And I also have to thank my partner Hans with his partner Giesel. Hans says, by the way, that the witch tried to cook Hansel and Gretel in exactly that oven. Okay, so I doubt his fairy tale veracity, but he's absolutely the best possible partner on this data journal. Okay, so I finished about when I wanted to finish. What I want to do is do a 3-minute demonstration. So I'm going to do this. Okay, I'm in Firefox. I'm going to open a new window, and I'm going to say global carbon budget. Let's use this one. So there's the Global Carbon Project. There's the project homepage. There's some news about the global. Here's the ESSD paper. There's the abstract. There's the authors down at the bottom. There's the data set. There we are. We're at CDAC. There's the 213 version 1. Here's the subsequent version, some plots. Nice landing page. We didn't have to sign in. We didn't have to register. We didn't have to prove that we belong to the EDU community. The data is just available. Grab it, okay? Let me go back here. Let me now go through ESSD. You know, it's no accident that we're on the top of that list. No, I mean, it's serious how we do it. I'm going to do a title search. We did, what did we look at? We looked at ozone. So there's the ozone papers. There's the German one. There's the Bodecker one. I'm going to look at this one because I happen to know. There's the data set. There's the DOI. We're on the ESA, European Space Agency website. Okay? I don't know. Fonda can tell you. One of the hardest places to get data out of is European Space Agency. You look down here, it says, download the harmonized data set, no password required, just click OK. A free data set from European Space Agency? Unheard of, okay? Let's go back. Let's go, let me see what I use for a title search. Let me go one back. That was ozone. Let's look for those pigment data. HPLC. Oh, they probably didn't use the acronym. They probably spelled it out. Pigment. I'm using the author field, sorry. Operator error. There it is. Abstract. Go down to the bottom, find the DOI. That one's at Pangaea. Download the data set. I just showed you a global ocean biological data set, a global carbon data set, and a global ozone data set, and we didn't have to log in once. We didn't have to register. It didn't ask us what we were going to use it for. We didn't have to wait for an FTP. We didn't have to get permission. Click and get the data, okay? You should be stunned. This is what modern data access is going to look like. And if we can't do it, we're going to be behind. So I'll stop there. Again, I need to thank Copernicus. They've really given us a leg up on this. And thank Hans. It's a wild ride. Every data set requires a, specific, careful personal attention. But I think you can see that for a small journal in a couple years, we're starting to have a big impact on important data sets. So thank you very much. I see some friends in the back of the room. So.
Do we have any questions then for Dave? Okay. Please wait until you get the microphone so that it gets recorded with everything else.
Thank you. My name is Nick. I'm actually an engineer, so not much of a science guy. But I guess in my generation, I'm kind of used to this kind of open access, like open source. I mean, the fact you can have closed source stuff is kind of odd still. So one thing I do have a question for is I know with these data sets I've worked with, you almost always have some sort of special utilities that work around it. So part of that is kind of the source code that goes with it. So it's not only you're just downloading like raw binary data from, whenever. That's kind of useless. It's a bunch of bits. So what about tooling that goes with it? Is that part of the data set? Is that something you guys, I mean, you obviously you've explained that you use it, you actually go test, you regenerate plots. Essentially, like to basically use the tooling they have, but I mean, how is that incorporated inside the data set, or is that done outside? Is that something else they can kind of like source control somewhere else, or is that just...
Our goal, that's a really excellent question. Our goal is to allow that user 10 years from now, and all of us who do coding know that software, everything, the number of things that will change in 10 years is scary, but to go back and reproduce that, which means the source of the raw data, the algorithms, the correction tool, the interpolation tools, and the product. If it's a user who's, so we want to provide that verification, okay? But our main user doesn't want to go through all those steps, right? So we want them to get a quality controlled data set in an accessible format that they don't have to find an interoperator to do, that they can work with, model it, compare it to their modern data, whatever. So we don't want to lose that long-term technical backup, but we also want to serve a user who probably isn't going to go through all those steps. Steve, did you have a question? No.
Hold on just a moment.
Thank you. I wanted to ask you about evidence for the recognition part of it, in kind of two different examples. One would be whether you know of statistics or simply examples where tenure committees would recognize, not recognize, or weight differently data set DOIs. And then the second is NSF, because I've reviewed NSF proposals, and proposers will say, this is an important data set, we're going to make it available to the community as much as possible. Would NSF, do you know, give it more weight if they said, well, we're going to publish it as a data set in a journal?
To your first question is, we are new enough, it takes 2 years to start to develop an indexing. So we've just started to be indexed by Scopus. In the next 6 months, we're going to be indexed by SCI, by Thomson Reuters for science citation. US tends to use SCI and Europe tends to use Scopus. In that case, the citation is going to look identical, okay? You're going to list your GRL citation and your ESSD citation, and they both have a DOI, and I don't think your review tenure committee is going to be able to tell the difference. What's tricky is Thomson Reuters is also trying to track the data sets themselves, okay? What you just got credit for from us is your data description published in ESSD, okay? But Thomson Reuters is testing now a tracker of the data set themselves. So you could say, how many times did that DOI get downloaded from Pangea or from NSIDC or wherever? So it complicates the career aspect of it, because you'll have one more on your normal CV list, but you might also have data sets that I contributed to. And I don't think the promotion and tenure process knows how to deal with that yet. Now, on the NSF question is, I think NSF is hopelessly behind on most of these issues. If you submit a new proposal to EU 2020, what your data management plans are, in fact, we have 3 examples, they say, we're going to publish a special issue in ESSD. And so they're using the ESSD process to actually answer the question, how am I going to bring this data back into wider scientific and public use? I'm sure that nobody's ever tried that with NSF yet. And I don't know, I have no idea if NSF would even know how to respond to it. Partly it's a building a community of practice, because if the reviewer of that proposal says, hey, why don't these guys just put this data in ESSD? It would solve all their problems. Once you get that kind of feedback going, then it would help. But in Europe, there are specific, new 4-year, 5-year programs where you look at the data management plan, it says special issue in ESSD.
I'll save Stuart some walking and try and ask two short questions. I was wondering if you could say something about the requirements or limitations on the description portion, and then also, if I already submit data to several places, neither of which is on your list, and I want to publish in ESSD, do I have to submit it to a third place, or is there a process for getting somebody else approved?
The first answer is we're on a gray zone between what I would call a purely technical data description. Here's how we did it, here's how we interpolated it, here's the boundaries, here's the error statistics, full stop, to what feels more like a science paper. Here's how we did it, here's how we analyzed it, here's the errors, and here's some plots, and it tends to show a long-term trend, okay? So somewhere in that zone is where we are. The paper that says, I used so-and-so else's data and I did this scientific analysis, that's not ours. So the description tends to be from a purely technical to a more filled out, you've read the carbon paper, that one's sort of in the middle. There's some that are longer than that and there's some that are shorter than that. But that's probably about what you need to know to use that data set. So we're trying for a middle ground there. No, we don't want to have you move your data around. We would rather work with you and that data center that's already holding the data to bring them up to speed with a registry system, with a landing page, etc. Because it's better if they're the holders and curators of that data, it's better that we build their capabilities rather than trying to shift it somewhere else. So we actually have many examples on that list where someone says, well, actually, Deutsche Wetterdienst, they're not a data center. They don't normally make data openly available. They make it available through WMO. So for them to all of a sudden come in and say, we're going to be a data center, we have a data registry, we're going to provide these landing services, customer services. But it was better than trying to move it from DWD, to somewhere else. So we would rather work with you and your existing data center to try and build that capability in more places. We're not trying to keep a short list, we're trying to build as long a list as possible.
I've already asked many questions, but I'll afford myself one more. How long is the process between submitting a data set and getting it published in ESSD?
We are as fast or slightly faster than any other Copernicus journal. And considering that our review process takes longer, if you look at the sequence, the step in our process that actually drags out is the revision and submitting a revised manuscript. In that case, we're a little bit longer, like 3.5 or 4 months compared to average 3 months for most Copernicus journals. But end to end, from submission to publication, we're actually a little bit shorter than the other journals. Now, the qualification is if you're going to try and do a special issue, because now you have to get permission from all authors. You have to get the data center to get sign off from all authors. So doing a special issue tends to slow things down. And I don't know that we're any worse than a special issue in ACP, for example, but I know there's more steps to get all these data permissions. So our special issues are probably a little slower, but our regular papers are as fast or faster as any of the other Copernicus journals. And Copernicus gives us the tools to track that. We're acutely aware of that issue.
Some of the Copernicus journals and EGU journals suggested to submit the data, whatever used for producing the figures analysis. Could you comment on that, where they are with that and how they're going to do that if they are able to accept those data sets?
Other journals do that. GCA, Geochemical Cosmochemical Acta, has always done that. If you submit an analysis of a core, you have to submit a spreadsheet as well. The problem is that encourages the minimum acceptable data set, right? I just have to put in enough so that somebody else can see what I did, as opposed to a fully quality controlled, validated data set. Second, I meet often. I meet almost every 12 months with both the EGU journal editors and the AGU journal editors. And the editors hate that. They said, the Excel sheet comes in, it's not formatted correctly, we don't know how to deal with it. So that's sort of a backdoor way that some journals are using. And if the data sets are small and in a reasonable format, it might work. But for complicated data sets, I don't think it. That journal, those editors and that journal are overloaded enough with their normal workload that they're not doing a good job. And they say that. I'm not saying that. They say that. We can't do a good job with this. GCA has been doing that, I don't know, almost 20 years. But they insist on Excel spreadsheets, and they can't be larger than such and such a file size. It's just the journal editor finds it a headache, basically. Where I hope in this case the journal editor is leaping at the chance to help you do that. That's really the difference.
So one comment and then a question. The comment is that we are starting to assign some DOIs to datasets here at NCAR on a fairly small scale, but we're kind of building capacity to do that. The question, though, is kind of going back to a previous question about the login question, free and open access with the fewest barriers possible. The reality is many data centers have logins for various reasons. Are there ways to get data center participation when they do have those logins that they can't, move, kind of sidestep?
A lot of data centers do have those barriers. They need to justify their public funding. They need to show who their user community is. Our answer is actually fairly simple. If you're moving in the direction of open access, everything that you do with the registration system, you can do with Google Analytics, right? So if you start to build Google Analytics into a DOI registered data, you get all that information. So British Antarctic Data Center, for example, they have a formidable, believe me, they really can do a barrier when they want to. But that's at the option of the individual data provider. So we're always pushing them to get rid of one step, to lower one step. So as long as we're moving in an open access direction, even if for legacy reasons you might have fences and barriers today, then we want to work with you to do that. If you're stuck in that mode and you're not trying registry systems and not trying analytics and not trying to build it, if Thomson Reuters is going to track dataset DOIs, you're going to have to drop those barriers because otherwise they're never going to see your DOIs, your dataset. So the answer is, if you're moving in the right direction, we want to work with you. I chose, what did I choose? Well, European Space Agency really surprised me for them to go that way. CDAC, we've worked with them. They started by minting one DOI per data set by hand, and now they've gone to a full registry, and then I showed a Pangaea one. So.
I seem to be, we're starting to run over a little bit, so I think we probably can finish up here. If you have any last questions, or would you like to? Okay, and let's thank Dave Carlson.